Ladies and gentlemen, I am Baiq Farida from University of Muhammadiyah Malang. I'm here to present the extended abstract paper about application of lean manufacturing to minimize production waste. I would like to thank Mrs. Annisa Kesy Garsid and Mr. Muhammad Iqbal Nur Hadi for their contribution on this work. And thanks for the organizer of ICEBM 2023 and all the sponsors to provide me with an opportunity to present our work. Well, now let's move to the next slide. Here are four main sections of this paper. The first one, we are going to the introduction part. It delivers the overview of the lean manufacturing concept and explain this research background. At its core, lean manufacturing is focused on improving efficiency while reducing waste. As such, there are five key principles that characterize lean manufacturing. The first one is defining value from the consumer's perspective. It means organizations need to have firm understanding of their customers' expectation in order to serve them with the highest level of value. The second one is identify the value stream for the product that provide the value that customers are looking for and determine how to reduce or eliminate waste along each stage of the stream. The next one is designing production flow by reducing waste. It's important to do because a significant source of waste is the disruption of manufacturing due to inaccurate supply and demand planning, where organizations suddenly have either too much or too little inventory. The fourth one is managing to schedule or produce based on customers' demand, or we call it pull system. If the production of goods only commences when there is demand, the organization needs to ensure that they are able to accurately forecast demand so that manufacturing never actually stops but instead stays constant throughout demand's ups and downs. The last one is improving the performance by continuously or decreasing waste, or we call it perfections, or it means analyze metric constantly so that areas of improvement can be easily identified in the pursuit of enhancing the customer's experience. Okay, the number of literature proves that the positive performance of lean manufacturing methods build the improvement system that yields goods and service with advanced productivity, decreased costs, and decreased lead time, eventually improving organization performance. According to the lean manufacturing idea, this study drives to identify waste in a lean concrete production. It found several waste activities such as the bottleneck between the inspection station and the less storage of unfinished product. Products that turn to the inspection station have to wait due to the limited capacity of storage area, which is cause the total production time becomes longer. And through lean concept, it's enabled to give improvement at the critical waste. This case study was conducted with a local concrete manufacturing company in Indonesia. We already collected 39 completed surveys. The data was obtained from the observation, interview, and distribution questionnaire. The questionnaire consists of 7 wastes including overproduction, defect, unnecessary inventory, overprocessing, waiting, unnecessary motion, and excessive transportation. And the study focused on identification waste at the leaning production line. To the best of our knowledge, leaning is concrete product used as drainage. It attached to the wall of the water channel to prevent erosion. The proposed framework's initial stage begin with generating value stream mapping or VSM that describe the flow of information and material flow. Then we need to distribute the questionnaire and performing by the weighting method to get the highest weight value which describe the critical waste. The following step is to determine value stream analysis tool or VALSAT. After receiving the questionnaire results, VALSAT is used to analyze waste in detail. The next step is to define the cause of the waste using fault tree analysis or FTA, and the final step is to provide improvement suggestion to minimize waste based on risk priority number or RPN from the failure mode effect and analysis or FMEA. Now we are in research results. And I want to remind that this research used survey method and there are 39 completed survey. The purpose of distributing questionnaire is to find out the dominant waste that occurs in the lining production by performing Barda method. Through the table 1, we find there are two critical wastes, including weighting and unnecessary inventory. Then the selected waste will be analyzed in detail to discover its causes. After discovering the critical waste, then we use fault tree analysis to find out the root cause of a problem. We know that weighting is the waste with the highest points in the lining process sent to the warehouse. Waste weighting causes lining entering the inspection station to be delayed because inspection lining cannot be issued. The biggest failure mode of waste weighting is product have to wait for a longer time before it transferred to warehouse. It is caused by the limited capacity of the forklift and the smaller number of operators causes waiting in moving the lining to the warehouse. The company doesn't have specific storage area, so the inspected lining is waiting for free space in the warehouse. Now we move to the causes of unnecessary inventory waste. The biggest failure mode of unnecessary inventory is storing raw material more than used due to the imbalance between stock and utilized material. It happened because the number of delivered product is more than ordered due to proof of purchase is presented in handwritten form. Therefore, miscommunication between the company and supplier cannot avoid it if the proof purchase have writing error, loss, or damage. Subsequently, both ways will be identified by the FMEA tool in order to find the root causes. The result of the calculation of the risk priority number or RPN in the FMEA tools show that waste weighting with the cause of limited warehouse area has the highest value. Moreover, since the product or lining have to be weighted due to limited storage, the improvement suggestion is to provide warehouse layout where each item has certain storage area. Thereby, weighting and the total lining production process time can be shorter. Then, we can conclude that the highest waste in the lining production process is weighting and unnecessary inventory. Based on FMEA analysis, the highest RPN value is discovered in waste weighting. Due to limited storage area, the proposed suggestion is to enable storage area for one type of goods so that the material handling process runs smoothly and that the lining waiting time is shorter. And moreover, the company can allocate operators to other workstations to transfer product. In addition, adjusting forklift feature will help to have more capacity. Okay, thank you for listening.